version right now. Subversion has a central repository model and Git use distributed approach. And we are going to work with Git. It's more than full fast distributed. Yeah. So there are two types of repositories. Repository is just a database of files, history of changes on these files. And because Git has distributed approach, you have a local copy of all repository on the local machine. And you interact with local copy, and after this, you are pushing this copy to remote repository. So the main providers of such remote repositories are GitHub, GitLab, and GitLab. I had experience with all of them, but usually I'm using GitHub for my pet projects, for my home projects. In my job, I'm using GitLab. What about commits? Commit is a snapshot of changes at a certain point in time. So here, how commit looks like when you typed git log with the stats comments in the command line. But actually, we're all using IDS, and it looks much prettier there, like in the first slide. Like this, you just see how what was changed with the beautiful syntax, values, and so on. So usually when you're developing task, you break down into smaller parts. You usually break down these tasks into small parts and commit each part to save your progress. So this really convenient if you would like to roll back to the previous step, and more commits you make, more flexibility you have to roll back to manage your task. So this is the usual commit flow. Commit small changes, commit with different commit messages like add user repository or maybe service, factory, and so on. And after this, you can push it to remote repository. Yeah, I recommend to push to remote repositories as much as possible. Because one time I had a big refactoring. I forgot to push all my changes to remote repository. I spent like a couple of hours in this refactoring, and I lost my progress because I suddenly removed a local copy of my repository and got the remote. It was very tough. Then branches. Git has a great feature like branches. It is a collaboration feature or just feature for splitting changes. You have main branch, and you have 3 developers working on the same project. So they can make their own branches and develop separately their features. And after this, you're merging all this main branch and you're forced to production. Or you have a test stage, a demo stage, test it first, demos. Yeah, merging. Combining all the changes, all the commits from one branch is merging it to another branch. Usually, flow is like this: will make branch from main branch, developing a feature, and merging to a branch. But for main merge, you should open pull requests, for example, to allow your colleagues to review this request
and approve. this merge. We'll talk about pull requests a little bit later. So what is GitHub? I mentioned three main providers of remote repositories, and GitHub is one of them. So this is just a platform for hosting Git repositories. You can create public or private repositories there. Actually, you can run your own repository management system in your own cloud if you want, but it is pretty hard. But if you like challenges, you can try. GitHub has different collaboration features. You can make pull requests, code reviews, open issues, and also it has project boards. Also, GitHub provides social coding. For example, you can search for different open source repositories there. Just we can check it. Like, example, we are visiting main page, and this is you can subscribe to different people and see the likes, like in social network. You can see repositories they stay at. You can visit these repositories. You can also make put stars on these repositories to save, for example, for future research and so on. Yeah. And you can also contribute to open source. You can search for these repositories if you like the project people develop, the person developing. But you find some bugs or issues there. You could clone this repository to your local machine, make some changes, and open pull requests to these projects and contribute to it, improving this project and help others to develop it more. What is pull requests? It's just a request to merge all your changes from one branch to another. Usually, I'm making pull request to main branch. Here's an example of pull request. You can see that you can left comments here. You can check. You can check commits, open conversations, and checks. Checks is just for GitLab actions, different pipelines that can test your code, check code style, and so on. So if all checks passed, you can merge it. So from the left side, it is list of files. So from the right side, it is changes of specific file. That's it. Well, what about issues? Issues, as I mentioned in previously, you could open features or issues in different open source projects to help improve them. You can also open like any random project and check these issues. It's pretty much. So here, contributors provide description of this improvement, or if you don't have time to make pull requests, you just open issue and describe what you want to improve or what would be good to add to this project. If you experts, you can check this code by yourself and add make pull requests by yourself with changes. And it will be approved later and merged to the main branch. So summary, small summary. So Git is a distributed version control system that excels at branching and merging. It helps to collaborate a lot with your colleagues and so on. Effective use of version control leads to better collaboration, code quality, and project organization. So let's try to go through this flow, and I will share you a link later. You could clone it and try this small Python script with HTTP request flow. So here we have absolutely empty folder, just a directory. It's a Linux directory. But we would like to put this directory on the source console. Let's go to CodeSeoul repository and make like the clean one, public repository. Just let's name it so backend. Yep. Tools like this. It will be public. Great. The next steps is to init this repository here. And let's check how it looks inside. This hidden folder was added. And this is the local copy of your repository. Don't remove this folder, please, before if you are not push all your changes to remote repository, because if you remove this, you will lose all your progress and you will lose a lot of time. No. Yeah. So here is a lot of different information about repository. Usually you do not care about all this stuff. So just for demonstration. Okay. So we made Git. When you create repository, you will get clear instructions how to initialize it, and step by step executing these commands, you will success. So let's check our files. I'm going to add a request lifecycle under source control. So done. Now we can commit it. All comments I'm processing, it's in your local repository. So I haven't pushed it to remote yet. We will do it later. For example, first commit. Great. And now we should connect our local repository to remote one. Let me just copy this. And git push to origin main. Great. That's it. So now we have our remote repository with one file. And this is public repository. You can scan this QR code and make a clone of this repository to your local machine and play with this small script if you want. And also you could put the star to the Seollal Bootcamp repositories for future workshops, not to lose them. Okay. Generally is okay. Let's fast check how we could collaborate using branches. So if we want to add to change something in your code and merge it into the main branch, you could do it like this. It's pretty easy. Cycle. So I'm using Nana. It's just for speed. Just for demonstration, let's change a couple of things here. My time. Oh shit. Oh. Okay. Hello. Using Git status, we can check that request lifecycle Python file was modified, and using git diff, we can check what was actually changed. Okay, let's return back and make branch. Okay, no changes right now. So we have created a new feature branch. Let's check it, check out to this branch. And so now we can add all changes we want in the separate branch. Yeah, we are here. We're making the same actions. Git add, git status. We edit this file. This is command line tool I'm using, but usually I'm using, for example, IDE. Let's check how it works in a more fancy way. I hope, yeah. Here we can see feature, our branch. You can make new branch easily here, and also we can check changes. This is more convenient, and actually you don't need to use command line tools during your daily work, but it's nice to know about all these things. So now let's make commit. And let's push to our new branch from the IDE. Cool. So immediately we can see the suggestion to make to open pull request to our main branch. here someone can enter and text why are you using this. Or maybe open issues. Issues is for, okay. So we can check comments here. You can answer it at React and so on. Let's resolve this feature or just merge this pull request. Confirm merge. After this, we can delete our remote branch. And that's it. We added new changes to our main code. And we can see that this change here. So that's how it generally works. Now we can discuss it, and if you have any questions, you could ask. Yeah.
Can you push also requirement stage requirement stage?
Yes, sure. Let's make it. Let's do it. I will push it to main branch without dirty work. So it is not recommended to push to main branch directly, because in huge projects, it could break all. Okay, done. So any other questions? Suggestions? Yeah.
Developers were doing the same project and creating the changes. And their changes overlap to each other.
Okay.
So
this is merge conflict, and you can you will see this merge conflict in GitHub when you're making pull requests, and when you, for example, someone push to the main branch some changes, you try to pull all these changes to your local branch, and in IDE you will see this merge conflict. And it depends which changes are main. Yeah. So you just you can approve your colleagues' changes, or you can approve your changes, but it could be different cases, and it depends on this merge conflict. If it is some changes in file versions, for example, library versions, you just accept the highest one. If it is merge conflict in logic, you will call your colleague and discuss together which changes are main, something like that. If you sure that your changes should be newer, you just accept your version, but it is better to discuss this merge conflicts with the previous author, like this. Yeah.
Were you directly editing the code in GitHub on that page? That you just were looking at Krishna?
You're talking about request lifecycle Python file? Yeah, I edited directly to GitHub, and you can clone it using this QR code. It is public repository. You can clone it and run on your local machine.
So you made a pull request.
Yeah, I made a branch, made changes in this branch, opened pull requests here, and just merge it using merge button to the main branch. Yeah.
How often do we have to commit our code?
I recommend to commit as much as possible. You will break your task to small parts and commit each part as often as possible to save this small progress. And it will be really convenient to roll back or maybe remove some changes if you want. Yeah, so no questions. Let's okay. Question. Yeah, question.
You showed some example for commit messages. For example, if it's feature or it's bug fix.
Yeah, we can check. Let's check a random project again, and I don't know. Let's this one. Example pull requests. So this like this. Edit support for phantom types commit. We can check it. Looks like this. But it is also depends on your task. Like if you're fixing a bug, you can, and this is small changes. You just fixing and put your message like fix this bug. That's it. And small changes will contain only one commit, and that's fine. If you're working on big refactoring or like complex task, every step should be described like edit service A, for example, then connected database, then made repository, then edit, I don't know, config files or edit environment variables like this, just describing your process step by step, like if you will describe it in real life, if you're doing steps when you're cooking or something else. Yeah, and let's try to make to create repositories. I'm not sure how to do it better.
I got it.
Yeah.
I got it. Can I use your computer?
Yeah. Mm-hmm.
All right, guys. So let's try to actually have you do this hands-on. Okay. So if you have your notebook open, right, and you should have most Mac OS and Linux will have Git installed already. Okay. So we're going to do it together now because we still got 30 minutes, maybe 20 minutes. So let's just walk through this together. All right. So can I just create a junk repository? Okay. So on GitHub, the easiest way to set this up is to start in GitHub if you plan to publish your thing to GitHub, which you probably do. Okay. So you start by just going to GitHub. Okay. So everyone on your notebooks, if you want to follow along, go ahead and go to GitHub now. Okay. Sign in if you're not signed in already. All right. And once you have got logged in, and click this plus button at the top here to create a new repository. All right. Go ahead and create a new repository. You're just going to create one on your profile right now. Earlier, Dennis created one at the organization, but for now, just for your practice, just do it in your profile. So you remember seeing this page. Okay, go ahead and enter a name like, Seollal, Bootcamp, Git practice, something like this, okay? And then public is fine. And then you can, if you have actually not started on your project yet, you can use these options to create a bunch of files for you, okay? And we're going to talk about these files in the next session, right? But for now, just click add a README file, okay? So you set the name, make sure it's public, add a README file. Everyone there so far? Good? All right. So now create repository. And so you have this empty repository with just one file. All right, does everyone see a page like this on their account? Good? All right. So now, open up a terminal. I'm going to go up one folder, is that okay?
Yeah.
And somewhere, if you're familiar with terminal, you can just navigate to a place that you want to keep all your projects. If not, you can just start wherever your terminal is and you can clean it up later, okay? But you can do git clone, okay? And then go back to GitHub. Whoop. Click the big green button. And then you get this thing pop up here. Yours might say HTTPS instead of SSH. That's totally fine. We're not going to cover the SSH stuff today. Unless you did, I don't remember. But yeah. So you can just click copy here. Okay. So click this copy button. Go back to your terminal. Paste. Okay. Command V if you're, or Control V. Or right click on Windows, I guess. And then it will clone down that repository that you made in GitHub to your computer now. Okay. And the connection between GitHub and your computer will already be set up. When you do a clone, it does the remote configuration for you. You're done. You don't have to worry about it anymore. From there, you can go into your folder. So if you're not familiar with command line, CD, and then the name of the folder, which is just going to be the name of the repository. Okay. Good. And then if you do ls to see what files are in the folder, you'll see that readme.md. Good? Everyone's there? Cool. So now, let's actually write some data. Actually, no, before that, sorry. As Dennis said earlier, do git status to see everything is clean. There are no changes. What is on your computer in that folder versus what's in the repository, they match. So there's nothing to do. But let's change that. Let's say we want to add data to the file. Okay, everyone's here so far? Yes? Just do something like echo, and then, Dennis is cool, right? Because he is a super cool dude, all right? And then you can use the greater than symbol to say, hey, take this text and dump it into a file. I'm going to dump it into our readme.md file, okay? And then hit enter. This should work on Mac or Linux, okay? And then if you do cat to show the contents of that file, you can see the file now says Dennis is cool. Okay, so everyone's got that? I only see a couple of head nods. I see 2, 3. Everyone else following along? Cool. No? I see a head shaking. Do you need a hand? Okay, where did Tom go? Ah. Can you either help him or go grab Tom?
Yeah.
If someone needs help, so raise the hand, and I will help you.
Yeah, so if you need help, just kind of go like this. Yeah, here in the back on the right. Oh, give me 1 second. Let me fetch one of the other helpers. All right, so to catch up our helpers, one in the back over here, and one over here too. These two. So to catch up our helpers, they created a repository on GitHub. They created a repository on GitHub. They cloned it down to their local machine. And now we're editing the README file. So now that we've changed that README file, okay, if you do a git status, okay, you'll see Git recognizes that we changed the file, right? This is in line with what Dennis showed you earlier. Okay, does everyone see this? Great. So now we want to tell Git, yes, this is a valid change. I do want to commit this to history. I do want this to be recorded in the source control. We can do that by saying git add and then the name of the file. Okay, again, just like Dennis did earlier. Okay, so you do that, and it looks like nothing happens. Okay, in Linuxy land, when you see nothing, that usually means things are okay. Okay, when you see a bunch of red text on the screen, that means there's a problem. Okay, but if you absolutely must check, you can do. Oh no, I don't know if I remember the thing actually. You can do that, $? And if it says 0, that means the last command ran successfully. Okay, that's a more advanced thing. You don't need to worry about it. But anyway, if you do git status, you can see now that modified is green. Okay, so it recognizes that that README file, it was changed, and Git will track it in history once you commit. Okay, nothing's been written to history yet because we have not committed. Okay, but everyone sees the green readme.md now, right? Does anyone not see this? Because that means you need help. Yes. Has everyone else got to this point? Great. So now, just like Dennis showed earlier, we've staged it, and we can now do git commit. Okay, we want to save it to history. -m to tell Git, hey, this is the message we want to store. And we can do quote updated README to reflect reality. The reality being that Dennis is cool. Okay. So now you want to make sure that you include that in quotes. Either double quotes or single quotes is fine. The reason is if you don't put it in quotes, it's going to interpret each word as a separate command. If you put it in quotes, it's all going to treat it as just one body of text. Okay. So once you've done that, you can just hit enter. It tells you, okay, here is the branch that you're on. Here's kind of a hash, just an identifier for this new commit, this new checkpoint in history. Here's the message that you gave. And then here's a summary of the changes. Okay. One insertion, one deletion. Deletion being like just an empty new line. The insertion being, writing Dennis is cool. So now, if we do git status, again, it shows empty and clean, but it says your branch is ahead of origin main by 1 commit. Origin, in this case, is GitHub. Okay, so we're ahead of GitHub by 1 checkpoint in history because we just made a change here. We have not sent that change to GitHub. Okay, so to send that change to GitHub, we just need to do git push. And now it says, okay, there were 5 objects. I don't know where the 5 comes from. We only changed 1 file, but it's crazy Git internal magic, so don't worry too much about it. But it counted the objects, it wrote the objects, and then it shows that in this repository, we took this commit in the main branch on GitHub and updated it to this commit. Basically, we moved forward a checkpoint in time. We took our checkpoint, we pushed it up to GitHub, and we said, hey, GitHub, here's this new checkpoint, here's this new point in history, and make the link between the previous point and this point. And so now, if you go to GitHub, you will see the README now says Dennis is cool. Okay? Does everyone have that on GitHub? Does anyone need help? All right. So now, awesome, thank you. Now let's say, you're working on this with someone next to you. Now, I was considering having you actually do this next Oh, that's weird. The color of the clock changed. We don't quite have enough time to do this next part, so I'll just describe it, and maybe you can try it on your own time. But you can, in your repository settings, you can add collaborators, right? Is it going to ask me to sign in? It's going to ask me to sign in. But you can go to collaborators here, and you can add other people to your repository so that they can work on it with you, okay? And that way they can make branches and do commits and all this kind of stuff, okay? Or better yet, what you can do is, one second here, you can go to some other repository, okay? For example, the one that Dennis set up earlier, and you can fork it, okay? Fork is something specific to GitHub. What it does is it basically copies a repository to your account or to another account that you control, but to your account, and maintains a link between the two, okay? So what we can do is we can fork the Seollal Bootcamp one, and you can do this on yours if you want, okay? I'm not gonna walk through everyone with this one because there's not enough time, but I'll just demonstrate. You can fork some repository, and this takes a moment. Also, Dennis, I'm so sorry for polluting your GitHub. We'll clean it up later. And you can then, you'll see, this is now in Dennis's account, not in CodeSeoul, okay? But it says forked from CodeSeoul, okay? So now I can freely make changes here, okay? I can make all the changes I want here because I control my copy of the repository, okay? Maybe I don't have permissions to change the CodeSeoul one, right? This is how open source works, okay? For example, Linux, right? Big giant operating system. Not anyone can just make changes to Linux, right? Because there's lots of trolls on the internet. So instead, what people do is they go to the Linux repository and they fork it. They basically copy it to their account. They make changes on their account. And then they submit a pull request where they request the original account, the Linux account. Hey, please pull the changes from my copy. Okay? So that's what we're going to demonstrate really briefly here. Again, I'm just kind of repeating what Dennis did. But I want to have this recorded in this manner so that you can follow along later, because we don't have enough time to cover everyone now. But once you have it forked, you can go ahead and edit the file. I'm just going to do the inline editor here. Usually I don't recommend doing it this way, but let's just do, I'm just going to edit this file. Okay. I'm going to commit this change. Okay. So imagine you've gone through the whole like change a file, add, commit, all that kind of stuff. Okay. So now there's a difference between Dennis's version of the repository and the original version. And GitHub knows this. It says this branch is one commit ahead of CodeSeoul's branch. Okay. Just like earlier, how our local was one commit ahead of the GitHub version, right? So now what we can do is we can just open a pull request. Then we can say, hey, CodeSeoul, please accept my change. And there we go. Now we have a pull request, again, similar to how Dennis did it, okay? But this fork change pull request workflow is very common, okay, for open source projects. When you're at a company, it's a little bit different because you will have access to the repository directly. Instead, when you have access to a project directly, the common practice, excuse me, is make your changes on a branch. Do your changes on the branch, push the branch up to GitHub, and then you can actually have a pull request between two different branches in the same repository. Okay? So I'm gonna, but I think that's what you demonstrated already, is that right? Yeah. Okay. So does that all make some sense now that you've gotten your hands dirty a little bit? Cool.
And we will on the contributors list.
Yes. So if you go to the, or if, yeah, so, so Dennis has 2 accounts here and both of them show up in the list. Yes. Cool. Other questions?
Basically, the fork from the original branch becomes the fork from the original report becomes kind of the branch, right? That
You could think of it that way. Yes. So for the benefit of the stream, the question was, so the fork almost becomes like a branch of the original repo. And that's a good way to think about it to help you understand. The key difference is that if you were to have a branch on the original repo, you would actually need permissions and access to the original repo. Whereas a fork, you don't need permissions to the original repo. As long as the repo is public, you can fork it. And then you have control over your fork. They have control over the original. Neither of you have control over each other. And the pull request is how the 2 different repositories exchange information. Okay? Yes. So any read operation you can do from the original. So if you need to rebase or pull and update or pull and merge, or I'm getting my terms confused. But yeah, that all just works. But for the reason forking exists is for write permission protection, right? Because the original repository, they don't want anyone random making changes, right? And when you fork it, you don't want anyone random making changes to your fork either, right? So forking allows people to maintain ownership, and then they can exchange code through pull requests. Does that answer your question? Excellent. Other questions? Yes. Oh, what is the difference between a pull and a push? Great question. So it depends on your perspective. Sorry, I'm totally not dying. So pulls, as long as the repository is public, anyone can pull, okay? And a pull is just saying, okay, there's some remote version of this repository, and whatever history they have, I want to copy that history to my computer. That is a pull. A push is whatever history I have on my computer, I want to send that history to some other computer, and they should update their history. Okay? A pull is a read operation. A push is a write operation. Okay? Therefore, you cannot push to any repository. You can only push to repositories you have permissions on. This is similar to the fork discussion we just had, right? So this is why you fork, right? Because you cannot push changes to some random open source repository out there. They won't let you. You do not have permissions to do that. But if you fork that one, you make a copy of it that you own, that you have permissions to, then you can push your changes there. And that's also why it's called a pull request, because you're requesting the original repository to pull your changes. You're not pushing your changes to the original repository. Does that answer your question? Excellent. Other questions? Cool. Thank you, Dennis. Cool. All right. Well, we have 10 minutes to the next session. So thank you, everyone. And thank you to Dennis for the presentation.
Disconnected.
And
Stop sharing.